So I was born and raised in Bulgaria, and I've always been fascinated with nature. But then the more I learned about biology, the more I realized how little we know, right? There's so much diversity out there and so many exciting questions that haven't been answered. And that I found really, really exciting. And unfortunately, science and career in science in Bulgaria is really not an option. Just because the country went through like a very severe economic crisis, and biology is very expensive. So I came to the US for college. I went to MIT, and that really was life-changing experience, right? I was able to do the science that I've always dreamed of. I was able to go to a lab, have a project, my little question, and get really exciting answers and like find out things that no one else knew. And that really kind of like solidified my decision that I want to pursue a career in biology. And after I graduated from MIT, I went to UCSF for my PhD, and I decided to apply for this alternative postdoc. Carnegie has the oldest fellows program in the country, but I'm very fortunate that they allowed me to do that here. Being a female scientist is very difficult. There's a big gender bias in academia. There's especially a big gender bias in the fellows programs, right, where most of the fellows are actually male. I thought I'm in a position where I have to choose between following my passion for science, having a family. My son was born 5 months ago, so it is very hard, but I think it is doable. A lot of female scientists hear that, right, that they have to make this choice between science and their career and family, and then the expectations from a female scientist and the expectations from a mother are just so much higher compared to her male counterparts. But the culture is changing, and I think leading by example is very important. I study the ribosome, which is the molecular machine that synthesizes proteins. Your entire body is made out of proteins, and who makes these proteins is the ribosome. So the ribosome is this unsung hero that does all the job but gets zero credit for it. You have millions and millions of these little molecular machines in your cells that constantly synthesize proteins. And what we're interested in is what happens when these machines break down. We need to know how our cells work, how proteins are being synthesized, so that we can understand what happens when disease develops, right? If you don't know how your car works, right, you really can't fix it when you get into an accident or if your car breaks down on the highway. So it's the same thing with like very basic biology. We understand the fundamental principles, and we understand how our bodies are built and how our cells are functioning. Because they're so fundamental, they're always contributing factors to such complicated disorders such as cancer and neurodegeneration. Oliver Sacks is obviously, he's a phenomenal physician and a scientist, but I think a really important thing that he did was that he was a science educator, right? That he was fantastic at communicating science to the general public. And I think we definitely need so much more of it. And we do need to put the effort as a scientific community to tell people what we are doing, why our research is important, and how this can affect everyone. So I think it's really up to us as scientists to better communicate our science and tell people the really exciting work that we're doing.